You are the first human being to stand on Europa, and the ice beneath your boots is cracking. Not loudly, not dramatically, just a soft, low groan traveling up through the soles of your suit and into your legs, like the surface is registering your weight and deciding what to do about it. The sound is almost polite, almost gentle. You look down and see a web of reddish-brown lines running across the white ice in every direction. Patterns so vast and so precise, they look like something drew them on purpose. The sky above you is black and absolute, the way space always is when there's no atmosphere to scatter light. Jupiter hangs overhead, filling a quarter of the sky, its bands of orange and cream glowing with reflected sunlight, close enough that you feel, irrationally, like you could reach up and touch it. It is the most alien and the most beautiful thing you have ever seen. For exactly 4 seconds, standing on the surface of this small, smooth, ice-covered moon, you feel like an explorer. You feel like the beginning of something. Then the ice groans again, deeper this time, and you remember where you are. Europa is the 4th largest moon of Jupiter, roughly the size of Earth's own moon, and from a distance, it looks like a billiard ball. Smooth, white, almost featureless, except for those reddish-brown lines lacing across its surface like cracks in old porcelain. Scientists call those lines lineae. They are fractures in the ice shell, caused by the gravitational tidal forces of Jupiter pulling and squeezing Europa's interior on every orbit, stressing the crust until it splits and resurfaces and splits again. The surface of Europa is, geologically speaking, one of the youngest in the solar system, constantly renewed, constantly breaking and reforming. It looks stable, it looks permanent, it is neither of those things. But here's the problem. The ice you are standing on is a ceiling, not a floor. Beneath the frozen surface of Europa, beneath miles of ice that has been cracking and reforming for billions of years, there is a liquid water ocean. Not a theoretical ocean, not a maybe. A confirmed, mapped, scientifically validated global ocean of salt water containing more than twice the volume of all of Earth's oceans combined, kept liquid not by sunlight, but by the same tidal heating that cracks the surface above it. Jupiter's gravity flexes Europa's interior constantly, generating heat from friction, and that heat keeps the water from freezing all the way down. The ocean has been there for a very long time, and the ice above it, the ice you are standing on right now, in some places may be only a few kilometers thick, a few kilometers between you and a lightless, pressurized alien sea that has had 4 billion years to develop entirely on its own terms. The cold hits you first, the way it always does. Europa's surface sits at around negative 160 degrees Celsius, cold enough to freeze carbon dioxide solid, cold enough that the ice beneath your boots behaves less like water ice and more like rock. Without your suit, the exposure would be measured in seconds before your skin began to fail. But the cold is almost secondary, almost manageable, in the context of everything else that is trying to reach you on this surface. Because Europa sits deep inside Jupiter's radiation belt, and Jupiter's radiation belt is one of the most hostile radiation environments in the solar system. High-energy particles accelerated by Jupiter's enormous magnetic field slam into Europa's surface continuously, stripping electrons, bombarding the ice, producing a constant, invisible barrage of radiation that would deliver a lethal dose to an unprotected human being in less than a day. The surface of Europa is being irradiated so intensely that the ice itself is chemically altered by it, producing oxidants and compounds that glow faintly in the ultraviolet if you know how to look. The surface is not just frozen, it is being cooked in slow motion by a magnetic field from a planet it can never escape. And it gets worse. Because Europa doesn't just sit passively inside that radiation environment, it interacts with it. The moon has a thin oxygen atmosphere, not enough to breathe, not enough to matter for pressure, barely enough to detect. Produced by radiation-splitting water molecules on the surface and liberating oxygen atoms that briefly collect above the ice before being swept away. It is an atmosphere born from destruction, renewed continuously by the same bombardment that would kill you. And as you stand on that surface, every second, the radiation is passing through your suit and through you, and the clock is running whether you feel it or not. But here's the thing about Europa that separates it from every other dangerous place we've discussed. The thing that makes it not just a physical threat, but something stranger and harder to process. It might not be empty. The ocean below you, that vast, lightless, pressurized body of salt water that has existed in the dark since before complex life appeared on Earth, meets every scientific condition we have ever associated with the possibility of life. Liquid water, chemical energy, organic compounds, heat, time. The same conditions that produced everything alive on Earth compressed into a sealed environment with no exits and no interruptions for 4 billion years. And this is where things change. In 2012, the Hubble Space Telescope detected what appeared to be water vapor plumes erupting from Europa's south pole. Geysers of material from the ocean below punching through the ice and venting into space. NASA confirmed similar observations in subsequent years. The ocean beneath Europa is not just sitting still. In places, it is pushing upward, finding weaknesses in the ice above it and forcing its way through, releasing material from the deep into the vacuum of space. This means two things that should stop you completely. The first is that something from below can get out. The second is that something dropped onto the surface. A probe, a lander, eventually a person, could, through contamination, introduce Earth biology into an ocean that has never encountered it. NASA's Europa Clipper mission, launched in 2024 and currently en route to Jupiter, carries a full suite of instruments designed to study these plumes, to taste what comes out of them, to look for biosignatures in the material the ocean throws into space. Scientists built an entire spacecraft to catch what Europa is exhaling. Think about what that means. Because if there is something alive in that ocean, it evolved without sunlight, without seasons, without any of the rhythms that shaped every living thing we have ever known. It evolved in pressure and darkness and heat, near hydrothermal vents on the ocean floor, where chemical reactions replace photosynthesis as the engine of energy, where the food chain begins not with light but with rock. We know this is possible because we've seen it on Earth. Ecosystems at the bottom of our own oceans, clustered around hydrothermal vents, thriving in complete darkness in conditions that would kill anything on the surface. Those ecosystems exist. They are not theoretical. They are full of living things that have no idea the sun exists. Europa's ocean floor may be lined with the same kind of vents, the same kind of chemistry, the same fundamental opportunity. And if life started there, it has had longer to develop than life has had on Earth. Significantly longer. But that's not even the worst part. The worst part is the ceiling, the ice, the surface you are standing on, and what it does to anything that comes out of the ocean. Because the same radiation that bombards the surface from above also creates oxidants in the ice, chemical compounds that, if they are cycling down into the ocean through cracks and fractures in the crust, could serve as an energy source for life. Europa may have a chemical conveyor belt, radiation creating fuel at the surface, cracks carrying that fuel down to the ocean below, where whatever lives in the dark uses it to sustain itself. A closed loop. A system that has been running for billions of years without any input from the sun. A biosphere that doesn't need a star. And if that is what Europa is, if that is what is happening beneath the ice right now, today, as you read this, then the implications for what life means in the universe are so large that they exceed anything our civilization has ever had to process before. It would mean that life doesn't need everything we thought it needed. It would mean that every ocean-bearing moon around every gas giant, around every star in the galaxy, is a candidate. It would mean that the universe is not empty, that it was never empty, that we have been alone only in the specific narrow sense that we hadn't looked in the right places yet. The Clipper will arrive at Jupiter in 2030 and begin its flybys of Europa. It will fly through those plumes if they are active. It will map the ice. It will measure the depth of the ocean and the chemistry of what rises from it. It will tell us, as definitively as any instrument can, whether that ocean is the kind of place where life could survive. It will not land. It is not designed to land. Because landing on Europa, putting hardware on that irradiated, cracking, dynamically unstable surface directly above an alien ocean, is a problem of extraordinary complexity that we have not yet solved. Contamination protocols alone require years of planning. The radiation would degrade electronics in days, Any drill system capable of penetrating miles of ice would be the most ambitious engineering project in human history. And yet we are going. We are building the tools, we are sending the scouts ahead, because something about Europa will not let us look away. Something about a world that hides an ocean under ice, that breathes through cracks, that sits in the shadow of a gas giant, and glows faintly with irradiated chemistry. Something about all of that pulls at the part of us that has always needed to know what is on the other side of the next horizon. You are still standing on the ice. The groaning has stopped